Testing, testing. All right. I guess we can get started with the next and final talk. Shh. Cool. All right. Okay, cool. I'll just wait for folks to grab a seat. So yes, you're gonna hear me. You're gonna hear me a lot today. So if you haven't met me already, my name is Ryan. I'm a staff engineer here at Shopify on the streaming platform team, and I'm the tech lead for the Flink platform. And what I'm going to be walking through today is our new Flink SQL toolkit. It's actually not quite yet launched, but very, very soon in the next week or so. And essentially the tooling for both humans and agents to iterate on Flink SQL. So to get started, I just want to give anyone who's not aware, hopefully not too many people, but a little bit about background in the breakdown of the Flink APIs that exist within the ecosystem. So we've got on the left the levels of abstraction. So I know in the previous talk, we were talking a lot about Flink SQL. And then on the right, we've got how the code is organized. So in deciding whether or not Flink SQL was going to be powerful enough to power data processing at Shopify, we were really evaluating some of these mechanics. And so we're going to start on the right in terms of we were within the data stream API, and I'll talk about the timeline in a second, but we were within the data stream API and found that this was powerful enough for us. And what we were worried about when moving over to Flink SQL was, is there enough power behind Flink SQL to actually be leveraged and at our scale? And the nice part about Flink is underneath both sets of APIs is the same low-level stream operators, and it's the same Apache Flink runtime. And so you'll see on the right, it's actually organized like hierarchical of like the SQL table planner is on top of the optimizer and planner that we were just walking through, which is on top of the operator API. So everything gets compiled down to the same plan, no matter what API you use, which is essentially why we were able to choose Flink SQL. So a timeline of Flink at Shopify. So in 2021, we introduced Flink here at Shopify, and it was using Scala at the time. And we were essentially amalgamating 5 different types of bespoke stream processing pipeline platforms into one single platform. In late 2022, back then we were really focused on data engineers. Like those were our core customers, and that's why we were able to leverage Scala, and it was a requirement. Essentially, you needed to know Scala. There was no AI back then. In 2022, we tried Flink SQL wrapped with Scala, and essentially what that means is imagine you have a variable within Scala, and it was just equal to some set of string, and inside that string was SQL. It was really the worst of both worlds, where you still needed to know Scala, and you also had to deal with the crap of SQL, essentially, right? And at that point in time, data engineers were like, I'm a Scala developer. Why would I do this? I know how to write Scala. And so that never really took off, but we were starting to get a glimpse of the power of Flink SQL, and everyone back then, it was starting to get a little bit hot. So in 2023, we migrated from Scala to Java. Really, the only reason is the open source community stopped supporting Scala. And in 2024, as people at Shopify were starting to really leverage Flink, they were like, all right, data scientists, I want to strut my stuff too, and I want to try this Flink thing, but I don't really want to know Java. What about PyFlink? I see that that's available. So we offered PyFlink for the last year and a half, and we have exactly 1 pipeline in production with PyFlink. So it turns out it's not exactly a good bet. And the primary reasons are a fewfold. One, operationally, it's way more complex. Like you have to essentially have a Python process running somewhere. You also need, it's also 4 times slower than Java just in general. And if you're doing stream processing, you probably want some speed. So just in general, I'd recommend if anyone hasn't tried it, it's probably not worth it, although they are working on a rewrite, so maybe after. And then in 2025, as we started to have more of these use cases of data scientists, data engineers, and really anyone wanting to leverage the platform, we decided we were going to take a bet on Flink SQL and really try it out. Back then, we were talking to companies like LinkedIn and Alibaba and trying to get the feel of how they were using these tools. And they really said that you could get about 80% of the pipelines that exist out in the ethos with Flink SQL, leveraging Flink SQL rather than Java. And so far, again, as long as you use SQL with UDFs, pure Flink SQL isn't enough, but Flink SQL with UDFs, you can really leverage and get about 80% of your pipelines using Flink SQL. And then also, just before 2026, we decided we were going to unify all data processing on Flink. And so actually now we have not only stream processing, we also have batch processing, which will come in later in the talk. So as we chose Flink SQL, we decided, all right, we were going to go all in on Flink SQL. This is the open source Flink SQL tooling that you got. It's called the SQL client. What's actually happening on the screen is not all that important, but imagine being a Java developer and you have JetBrains. For anyone who has used IntelliJ before, it is the holy grail of IDEs. especially if you have the full edition, and then you all of a sudden have no tooling, no debugging capabilities, no capabilities at all when you move over to Flink SQL. It's a hard sell for sure. So in 2025, the team built what we call the Flink VS Code extension here at Shopify. And this was meant to be our way of essentially iterating on Flink SQL. And so this was, I'll just break down what we're looking at here. So up in the top left, we have these session clusters. So we connect both to local clusters and remote clusters. This allows you to essentially use what's on the right. And the right is a notebook-esque experience that allows you to essentially iterate on your Flink SQL and actually execute. So you would connect to a session cluster and you would execute the notebook code, and it would essentially run out down the bottom a materialized view or an event stream if you wanted to see a changelog stream, or an append-only stream, depending on what you're looking at. And then on the bottom left, we have the Flink catalogs. This essentially was a way for you to explore some of the data that we have at Shopify. And so we use a lot of catalog stores here. And that way you could actually explore what's going on within the Shopify data warehouse. All this being said, this is great, but we're still lacking some capability that you have in Java. And so something also happened in 2026. There's this thing called AI, and no one opens an IDE anymore. At least, I don't know about you, but I barely open an IDE anymore. So developers have changed the way that they use their IDEs, and our tooling has to follow suit. And so what are the platform requirements now? Well, your platform needs to be AI compatible. That's the tooling that you need to offer. So developers need to be able to use AI to create and iterate and explore. And the tooling needs to be both human, which was Flink VS Code, but also agent-friendly, which Flink VS Code was not agent-friendly. It also needs to offer stream batch unification, as we're really trying to leverage and reuse the same components, the same logic in both streaming mode and in batch mode. And we also need a clear path to production. So there's two things in there. You want both to be able to test your Flink SQL, but you also want the artifacts that you explore with to be some sort of file-based system that you can check in. Otherwise, you're going to be doing copying and pasting all the time. And I'm sure a lot of folks, if you've ever written a data pipeline here, you've probably experienced what I'm talking about. So the Flink SQL Toolkit features. So it's CLI-based. So LLMs are great at leveraging CLIs, and it can be the backbone for both machines, humans, and other tools, which I'll show you at the end of the presentation. We also need SQL templating. And so this is allowing you to reuse and inject those statements that I was mentioning before. And it also really allows for supporting the stream batch duality. So if you're not aware with batch, because I'm sure most people here probably use Flink for streaming, because that's what it's known for, but there's actually minor differences in the syntax and what is possible with batch. A good example is session windows aren't actually supported within batch. So you might need to change your logic just a bit. The other good example is, at least an issue that we have here at Shopify, is we have different environments, right? You might have dev, staging, production, and either the logic might change a little bit, or even the names of the objects might change a little bit because of connector properties. And so you want some sort of templating to be able to get around needing multiple types of scripts just for the same logic. And finally, SQL testing. So with Java, you have JUnit, great framework, and it allows people, when they push to CI, to feel comfortable with what they're changing, right? Now, Flink pipelines, we'll get into changing Flink pipelines in general. It can be a little bit dicey, but at least when you publish to CI, you can at least feel comfortable that your SQL testing, at least your inputs and your outputs, would be validated. And so these are core features that we needed to offer. All right, live demo time. We'll see how much we'll get wrong along the way. So the first thing that I want to show is the CLI. So this is a custom bespoke CLI that we're planning on open sourcing. No promises on timelines, but that we're planning on open sourcing. So what it's going to do is it's going to manage your Flink versions for you. It's going to manage your Flink clusters, both the remote clusters and the local clusters for you. And then also it has a bunch of custom functionality around SQL itself. And what I'm going to show you just a snippet of what we have to offer. But hopefully it'll give you an idea of what's possible when you build essentially the right tools, or hopefully the right tools. So what I'm going to show you today is we've got a bunch of different custom versions of Flink. Is this big enough for everyone? Yeah, okay. We got a bunch of custom versions of Flink. So if you also are a big shop, you probably have commits on top of Flink. So this is just our fork. And so we're going to use this SQL testing demo version. And so we can install different versions of Flink, officials from source, or custom versions as well. And then what we're going to do is we're going to create a cluster. So creating a cluster, I'm just going to call it SQL testing demo to align with the label. Oh, I did not. I can spell testing demo, and we are going to use that version. So what's happening in the background? It's actually creating a bunch of different daemons on your machine. You can do a daemon list, you can do a daemon, you can do it IP based, you can do it hostname based. There's lots of actually different options in there. But what essentially is happening in the background is it's hosting a session cluster and a true session cluster on your machine. So unlike a mini cluster that you might use with Java that doesn't actually have networking between them, this is actually a true session cluster. So if you have any network components that you want to test, this is actually using the network within your machine. And so if we want to just do a simple contrived example of running a SQL statement, so we've got echo select, so this is just going to print out 1, or it should. And we got, sorry, I actually have to use the cluster. If I Flink cluster use, and we're going to choose to use this one, so I don't have to specify it later. And we're going to do echo on the select 1 and Flink SQL run. So what this is essentially passing in is passing in select 1 as a standard in. So this is going to be your SQL statements, and you can imagine you could run anything. And so what's going to happen is it's going to execute the statements, and you'll see here it's actually got the operations. So the op, if you don't know, it's the change log mode. So this is an insert, and the expression is 1. And so it's a lambda expression, so that's why you see expression 0, but you see 1. So what's really cool about this is is going to be a contrived example. I'm going to show you a full agent-based example in a little bit, but this is essentially all of the foundations that you need for agents to essentially iterate on your Flink SQL and actually both explore your metadata as well as actually iterate. So building on top of this, we say, all right, we've got some foundational components, but we still need this SQL templating and we still need SQL testing. So what I'm going to show you next is some SQL templating. So we have here a .flink SQL file. This is essentially what the VS Code notebook understands as a Flink file. Again, this is big enough. Yeah, okay. I'm actually going to start in the config.yaml. So what's happening in here is we've done a factory pattern for templating. Jinja is quite popular amongst data scientists. It's also popular at Shopify. And so we've decided to implement Jinja to start. But when we open source it, you can really choose whatever templating language you want. And you implement some sort of interface. And what essentially this is going to do is it's going to call out to your template engine anytime you want to render your SQL. And so this is essentially saying, all right, I want to take a profile. So we have different profiles here. You see dev for local. We have staging. We have production. We also have batch. And there's variables in here that you can essentially interject if you want to change things based on variables. So you'll see some are configuration properties. We've got parallelism. We've even got where statements that might change it. We've also got configurations. So these are Flink configurations that you'll want to change with set blocks. So if we actually look at our Flink SQL, you'll see at the top we've got macros that you can essentially interject, similar as just Jinja anywhere. And so if we take a look, we'll have BigQuery here. We have DataGen. We have Kafka for different environments that we want to use. And then when we actually want to execute it, so this is going to be our source block. We have a bunch of sales columns at the top. And if our profile name is dev, we're going to use a DataGen source. If it's batch, we're going to use BigQuery source. And if it's anything else, which was staging or production, it's going to use your Kafka source. So it's essentially a way to leverage the same logic, which you'll see is a bunch of these temporary views with selects, stars, et cetera, order bys. And you'll see all of the logic is more or less the same, but the inputs and the outputs, which is really nice. And so if we go back to our terminal and we do Flink SQL render, and we could choose which profiles, we're just going to render all of the profiles. It builds out the artifacts, and these can be checked in. And this is actually the artifact that you're going to take to production and you're going to execute in production. All right, so now the templating is all more or less solved. We're going to go to testing. And so under testing, we have a YAML-based spec that we designed. The first thing I want to show you is just the name of the top. That's the name of your test. We've got description. And then next we have execution mode. So there's two different modes, again, Shopify that we're leveraging. We're leveraging streaming mode and batch mode. I'm going to start with batch mode. The next thing I'm going to point out is target. So if you don't know how Flink designs the DAG, directed acyclical graph, it's essentially building a constructed massive DAG that could be n operators long, right? Now, in your normal program, you might want to test some subsection of some minor operation, some where clause, something small. And so what we've done is we've actually allowed you to test any subgraph of your DAG. And so what'll happen is this is the target object that you want to test. And then what it'll do is it'll essentially say, okay, have you given me all of the inputs that go into that subgraph to make it a valid subgraph? And so this is the inputs of sales, and these are all the rows that we want to pass in. And we're going to expect a materialized table out of this. And then I'll just do it here because it's a little bit easier to see as I'm going to be modifying it and showing you. If you do Flink SQL test, it's actually going to run all of the tests in this folder. You can pass a file if you want to run only a single one, but it's actually going to run all of the tests and make sure, given the SQL that you're running, it's actually validating both the inputs and outputs for whatever subgraph that you want to execute it against. And so just to show you that it actually works, we've got our materialized on shop ID 1010. We're going to just change it to 140. The IDE is actually smart enough to realize, no, it's supposed to be 150, you goof. But if we run it again, it will actually fail. And so what's nice about this is in CI, it will actually fail if you're like modifying your logic or you just want to change something in your either logic or your test. You can actually validate that it's actually correct. The next thing I want to show you just briefly is the streaming syntax. So the only major difference in streaming is that you'll have a potentially result mode of changelog. So again, as I was talking about before, there's changelog streams. So this has insert updates before, updates after, deletes. And so we have the same sort of inputs. We have 150, except it's for the same shop ID. So there'll actually be a retract before and then an update after with a new event. And so if we change this to 140, and again, we run our SQL test, it will fail with the output of, hey, your actually total amount is 150, not 140. And so it works also for changelog streams as well. So now that we have SQL testing, SQL templating, I'm going to show you how agents can use this code. And so I'm going to cheat and I'm going to copy this. So what's happening in the background is I'm just setting up a bunch of the different environments that I need to. So I have like the CLI installation. I'm creating a cluster. I'm doing a bunch of different stuff. So you can hang on with me as it's all installing. And what we're going to run, and it's an AI agent, so it's not deterministic, but we'll see. I've tried it a few times. But essentially what we're going to try and run is we're going to run an agent against some data sets just that we have locally. But imagine it's hooked into your metadata store. So we use Dataplex, and you can essentially just get it to explore, right? Like, so it can do the exploration of what data exists. And then this can actually also then execute against that. So the CLI is hooked up. Currently, it's hooked up to my local cluster that I showed, but we've also hooked up remote clusters. So these remote clusters are Kubernetes clusters, Flink clusters on Kubernetes that we have like auth essentially to. And I'm going to talk about some of the downsides that we need to improve. But what's nice about this is this actually has access to production data. So if you want both the scale of a Flink job to be running with like hundreds of task managers, you can use this remote processing that can't actually happen on your laptop. But it also has access for anyone who's done data processing and tried to do it on your local machine before. It's a pain to get data onto your local machine, especially at a big company. Data rules are very strict, but it's actually more the access that's really strict, right? And so sometimes it's just copying data to your local machine. That's the hard part, not actually accessing that data. And that's the part that we were trying to limit. So now that my agent is as well, I've set up everything before my agent, we're going to essentially copy this out. And as I run it, I'm just going to walk you through what exactly I'm asking. So I want to write an agents.flink SQL. I want to read data.orders and data.tracking. This is essentially two different JSON files that I'll show you in a sec. And I want to build a view that shows the current order status. And I want to see what's in that order status at the end. This run.sh is just a bunch of scaffolding around it to make it run a little bit simpler in terms of telling it what cluster and so on and so forth. You could put that in a Cloud MD if you wanted. So what I'll show you here is, oh, sorry, let me swap to Flink tools and zoom in a bunch. Agent demo. So the data exists in here. It's just a simple new line delimited JSON. But again, imagine it's your metadata store and you can actually hook into something like that. And so what's happened in the background is it's actually written this agents.flink SQL, and now it's going to run it. And every now and then it gets a little confused. It destroyed the session. Just use the session and print the result. Let's see, maybe it'll, there we go. All right, it was able to actually do it before I prompted it again. But essentially, the cool part about this is you can ask it to do something, it'll actually go do it, and you can iterate on it, right? So what it did is it actually wrote out this agents.flink SQL file. Of course, it could also template it and render it out, but it actually wrote out exactly what you might expect, which is super, super cool. All right, back to the slideshow. All right, so what's next? So improve shared clusters and exploratory console. So like I mentioned, the shared clusters are actually great in a lot of aspects, but suck in other aspects. Because it's how Flink and the scheduler works, we have a shared cluster for everyone here. And so it's a shared GSA. So that means that the data permissions that are available on that GSA are like bare minimum, right? This is what everyone at Shopify has access to, or everyone who has access to data at Shopify has access to. And so what we would like to do is we'd like to improve the Flink scheduler to essentially allow for multiple inheritance of IAM. So when you actually execute your code, it's using your credentials, right? Like if you have access to private data, or you have access to data that other people don't have access to, you want to be able to use this, this compute node pool as well. So that would be really nice. And then on top of that, essentially having an exploratory console, which I'll actually show you a prototype in a little bit. But that's more of a human-based console, right? So I've showed you a lot of like agentic tooling that works, and it also works for humans. But sometimes you just want a console to play around with and kind of just dig around. And if you've used BigQuery before or Snowflake, honestly, I think Snowflake's console is great. That kind of console is currently there's no existence for something like that unless you use something like the SQL client, which is eh. The next up is coversion UDFs. So if you weren't here at the last discussion, we talked about how we leverage UDFs, user-defined functions at Shopify. But just as a reminder, we support globally versioned UDFs and their namespace. So we have a monorepo, and essentially how it works is you check in your UDF into that monorepo, and it builds the artifacts and makes it so it's globally available for you. So you can use those UDFs in your Flink SQL, but it's a different PR today. So imagine a world where that UDF is actually co-located with your Flink SQL, and the thing that you want to deploy is always going to be your Flink SQL or plan, which we didn't get into today, but that's also supported in the CLI. Flink SQL, you want your Flink configurations, and you want some sort of user jars, right? And those user jars can include UDFs. And so imagine a world where the UDFs are actually co-located and co-versioned with your SQL and not globally namespace. So it can be checked in the same PR. I mean, in a monorepo in theory, you could do that, but it's not as nice. And finally, we've got state compatibility tooling. So as I mentioned before, with SQL testing, it's great. You can modify your code, and then you have SQL tests that'll validate that it's incorrect. And then you change your tests, and you're like, okay, great. Now I want to take this to production, and you realize state incompatibility. I'm sure you've all had to deal with it before, and it sucks. So a lot of people, how they essentially figure out you have state compatibility is you try to deploy, and it fails, and you have downtime. And for a streaming solution, that's not great. And so if you are using blue-green, in theory, you don't have downtime. But in most cases, you do actually just try and fail, and then you have to figure out, hey, I either need to restart with no state, I need to iterate or move forward. So we want to preemptively tell you which snapshots are compatible and which aren't compatible. And because we have your plan, we have your SQL and we have your plan, we can actually tell you if that plan is compatible with a snapshot that you're essentially wanting to restore from, right? And the other thing that I'll mention here is that the state that we're essentially validating against is something that there's no reason that we can't check it immediately. And so when you want to deploy, we should just be able to check it for you. So I'm going to show you a quick version of a console prototype that I think is quite interesting. And again, I've got my handy scripts that I'm going to use. So all this is doing is just installing and setting up a backend server. And that backend server is actually hooked into, this is tiny, but just imagine this is what a console could look like. And so inside this console, we've got a bunch of different commands, and this is actually hooked in through the backend that's running on your local machine to the local sessions, the local session clusters, but it's also hooked into your remote clusters. And you can run any of these commands. So if you've ever used, again, Snowflake before, you can run either a statement, a selection, or all of it. And you can hook into and see all of the different jobs. You can click into those. If you want to run multiple statements, you can run it as like so, and it'll run multiple statements. If you want to run and create tables, drop table, it's not actually existing. If anyone wants to change Flink, making it so you can drop or create or replace, please. Everyone hates it. But essentially, you could run it as long as you don't try to drop the table before it exists. You could run it, and I'll actually create the table in the select from. And what's really cool about stuff like this is you can build full ecosystems around it. So you have tables here. Everything's going to be an object, and so you can actually like preview rows. You could describe. You could do anything more or less you want, and with a bespoke API or bespoke UX on top of that Flink SQL. And so everything that's actually happening in this UI is leveraging the CLI in the background. So it's actually routing back to the CLI. So yeah, that's it for now. Are there any questions?
cool talk. I got a few questions. First question, let's talk about the AI bit. You kind of touched a little bit about the governance, IAM, control, permissioning bit. How do we ensure that the agents aren't going to write some inefficient SQL and basically burn your budget?
So inefficient is very different than governance. The governance piece is, so everything's local, right? If you have access, at no point in time did I actually show you data that we've scraped from some external system and gotten it on our local. If you were able to do that, that's a different system than mine, and that's responsible for the governance. With the remote clusters, how we've set it up is the remote clusters has the shared GSA, and that shared GSA has limited permissions across to access any data that you want. In terms of, is it efficient SQL? That's an additional expansion that essentially we can do. So we're also building a deployment control plane that will take these rendered artifacts and know it to deploy it. And at that point in time, we can do things like state compatibility tooling. We can do like validation that you're actually efficient using things like Daniel's plan. And like, because we have your full optimized plan at deployment time, we can do a ton of different things. Yeah.
Cool. Just next question. When it comes to the testing, the testing, if I understood correctly, like you're kind of testing individual functions, is there sort of an integration testing or is it all unit testing? And how does the integration testing work? And is this all Flink local runner under the hood or something else?
No, it's actually fully bespoke. It's something we're planning on open sourcing, but it's going to be a new module within the Flink table planner under SQL. So first, to answer that second part first is no, it doesn't use the local runner. It actually builds operator graph itself and then essentially runs it so they can figure out the subdag. First question, in terms of is it unit testing or integration testing? It's definitely unit testing, so that's where we're starting. We decided to start with unit testing because, well, one, it's easier to build, but two, essentially, we have lots of different connectors at Shopify, and for every single connector, you would need some way to run it both on your local machine, in CI, and all of that sort of stuff. And so we were just trying to get a bit first bang for a buck, but the idea of how to essentially test the full pipeline, you can still do. And I would almost postulate back that the integration part is hopefully not the core developer's responsibility. That's my team's responsibility that's responsible for making sure the connectors are correct. So when I was talking about what you actually deploy, is you deploy your SQL, you deploy your Flink configurations, and you deploy your jars. My team is responsible for the connector jars and essentially like a foundational layer. And so we're responsible for making sure the connectors work. So all that being said, integration tests definitely need to come, but we're starting with unit testing.
Cool. Just one last question. In terms of observability, you're automating a lot, you're building a lot of cool tooling. The learning curve has probably gone down, which is a good thing, but it'll be quite easy for someone to shoot themselves in the foot. Are you going to be monitoring all these jobs? Is that another team? How does that going to work?
Yeah, so how Shopify, how it works is if you build the data pipeline, you're responsible for it. But we have essentially tons of observability baked in. So when you spin up a Flink job, you essentially have access to our shared dashboard that'll show you everything you would ever want to know about a Flink job. And then you would essentially set alerts on top of that. So we'll probably have, it's not something we have today, but we'll probably set up some foundational alerting on top of that. But then we also, on our team, we manage the infrastructure. So if there's tons of jobs that are essentially restarting, we'll also get paged in terms of, hey, we should reach out to XYZ. Or if somebody's doing something nefarious for the entire fleet, then that's also something that we'll look into. The only last thing I'll mention is for the remote session clusters, which is almost an interesting thing of you can almost have runaway jobs because you start something and it's running in some ethos, right? We actually terminate with extreme prejudice. So after 30 minutes, you're done. We kill you. And this is mostly to both keep costs down, but it's not meant to be someplace. Like these remote session clusters are not for production. They're for essentially local development that you're essentially iterating on. And so those get terminated. And the other thing that we've had to do is we actually have like, it's open source. We have PRs up, but they're not merged. Essentially data governance that will essentially allow you not to insert anything back. And so this is actually a read-only mode that we've added to the SQL gateway that'll essentially only allow you to read on top of that session cluster.
Great talk. In terms of the testing side of things, when we're in Java land, we have, line coverage, branch coverage. How do you know the tests that are being written are of high quality?
Good question. You don't. Admittedly, yeah, we don't have that baked in yet. Like anything with testing is, you can fake testing if you really want. And admittedly, agents are great at that. So no, it's definitely up to the user and I guess their agents to write good coverage for sure. My hope is at least you have not an end-to-end in terms of integration testing, but like top to bottom full DAG. But then from there, if you want to test any sub DAG, it's really on you. There's no coverage tooling. Yeah.
Awesome. Thanks.
I'm curious if you have a take on, you mentioned Flink SQL handling sort of 80%, making the target. In the world of agentic programming, is it worth it to use Flink SQL? Do you drop down an abstraction layer and get the agents to just write it because they can, and we can avoid all of this SQL nonsense? Or is like this sort of the fact that everyone knows SQL still the deciding factor to sort of invest in that?
It's a good question. I think, admittedly, I don't think we know yet. I still think the barrier to entry with Java is still higher in terms of the actual writing of the code was almost never the fundamental issue. Everyone would come, and honestly, this was the biggest and part of the reason why we implemented PyFlink was, hey, I don't want to know Java. I want to use Python. And then the realization, it's not actually the language that's the fundamental barrier in most cases. It's the operational complexity. And admittedly, the operational complexity of SQL is actually much less, where my team can take on more of the responsibility, where essentially you just give us your SQL versus how at least we've structured Java so far, which we might also alter because Java also realistically only compiles down to a plan. But as of today, how Java works is essentially gets bundled into a super uber duper jar. And that's essentially what gets pushed down. But like if you ever have dependency conflicts or you ever shade wrong or you need to insert another jar, good luck. And that's, I think, more of the issue with when you choose something like Java. So I imagine, we'll see, time will tell, but I imagine SQL is still going to be the preferred use case. And especially when exploring, I imagine things like the console, that's going to matter so much more when you're using things like SQL. Yeah.
Cool, thanks.
Interesting talk. I have a few questions about the testing.
Sure.
The first one is, so when you run the test, will you consider the sources and the sinks of the job? Like, will you simulate them or also include them in your test?
So no. How it works is essentially, so this goes back to the integration testing of like sources and sinks are essentially removed. And how it works is you essentially, if you are using a source, it's a mocked source that inputs the rows. Yeah.
Okay. The second question, I think you just mentioned, you can test like a part of the whole query. How did you do that?
How? Good question. He's not actually here. There is actually a flip that's going to go up for it. We're hoping to open source it. But essentially what he's done is using some really low level of parts of the API. And so this is where like we were asking about the local runner. We weren't able to use the local runner. We essentially rebuild the DAG based on like we build the full DAG and then we deconstruct the DAG to then rebuild the DAG to essentially run it against.
Yeah, because as far as I know, like as a developer, usually you should not be able to know the compiled DAG from the SQL source.
So that's where you're not actually passing a part of the DAG that you want to test. It's almost like I was explaining to this group as like a subgraph, but what you're really testing is you're testing an object. And so everything within Flink SQL is an object, right? Like functions, procedures, tables, views. And so what you're passing to the testing framework is the object you want to test. And so that'll be a table or a view that you want to test. And so you're not actually saying which part of the subgraph you want to test in terms of needing to know the actual operators. But what it's going to do is it's essentially going to say, okay, this is the target, and these are all of the sources that need to go into that target, and that'll build the subgraph.
Okay, thank you. The last question is about the test for streaming queries.
Yep.
Will you only care about the final results, or you also check the intermediate results?
So it depends on your result mode. So that was where I showed the materialized table versus the changelog table.
Yeah, because even for like if you use more than one parallelism to run the query, sometimes the intermediate results will be unpredictable.
In terms of, you're talking about like ordering?
Yes, ordering parallelism. Let's say you'd like to sum a few numbers, and the intermediate results will depend on the coming order.
So you're talking about, are we talking about internal consistency here, which is a whole other conversation?
Yeah, that's
Yes. Okay. Okay. Good question. Yes, there's still some conversation around internal consistency. If you don't know, there's a great blog on it. Read Scattered Brains. But so first off, the default parallelism is 1. So by definition, it's the standard unit testing framework. We do actually offer parallelism above 1 with some like you're on your own kind of vibe. And actually at parallelism over 1, we offer, or we essentially say that there's no ordering guarantee, and you're like the deterministic result of parallelism over 1 is definitely more difficult to test. So we say it's there, but more or less parallelism 1. In that case, you don't have determinism issues.
Yeah. Thanks.
No worries.
I believe this is great because, as you mentioned in the beginning, one of your goals is to have more people using it, or even AI agent using those things. We're trying things similarly, but one of the challenges is like moving to production. So I bet Shopify has a bunch of data, and like when you build that, you run the tests. Okay, it works fine. Let's push to production, and there is always that subset of the data that you don't have a use case for that, or when you move to production, it's just gonna break and generate the wrong results. And as it starts to get more popular, more people using it, how your experience has been in this case? Or maybe because it's just wrong on this subset of data that was there, or because someone built a query that is just 2-3 times lower than the previous query and then messes everything downstream from there. It's more like how the adoption has been, your experience here.
Yeah. So specifically for this tooling, it's like brand new. Honestly, we're pushing it out either the end of this week or the end of next week. So this particular tooling is not yet widely adopted. In terms of Flink SQL in general, I think there's a few different questions in there of like, okay, what if your data is wrong? What if your schema is wrong? What if like all these things? Admittedly, SQL itself requires that the data, especially across environments, like there's some aspects that you just need to have good data hygiene in terms of you need to have the right schemas, you need to have the right data inside the actual columns itself. And so that is never going to be fixed by a transformation engine. I mean, they're trying with side outputs and all of these sort of things within Flink SQL, but that realistically is never going to be solved. But in terms of general adoption of Flink SQL, we've still noticed that there are cases where people need to still go back to Java. Admittedly, like Flink SQL is not it's going to solve for everyone, but we have seen that Flink SQL does offer a lot of capabilities to a lot of people to get started a lot faster. And so just to give you an idea of like a first Flink Java pipeline used to be, this was pre-AI, used to be like 3 months. Now I'm sure it's significantly less with AI, but like it was genuinely a long tail to actually get something up. And what people could do in like a day or a week, again, probably even scaled down with AI, but what people could do within a week was like honestly astronomical. And so widespread adoption is quite easy to justify. And I think it's only going to become easier as AI agents, like essentially learn more. All right, maybe last question and then. Yeah.
I usually get cut off right before that happens.
It's okay.
So just kind of stepping a little bit back out, this was really interesting. I just wanted to ask about the motivations for this, right? You outlined the problem very nicely, but what kind of motivated you to say, hey, I think if we build this tooling, if we take on this complexity, we'll be able to accelerate what people can do on fast timelines, we'll reduce the load on basically insights. And what are some of the things then that concentrates as far as difficulty in your team? Because there's a lot of functionality inside of SQL, and then there's all the functionality with inside of sources. So like, how does that become manageable where the trade-off is like, you guys are really, really good at software and getting the platform to run so that other people just have to think less and the interface is involved?
Yeah, I mean, honestly, it's always a prioritization issue. There's always another team that wants another thing. And so it's trying to find the most important team that's doing something that we need to essentially unblock using some feature, right? And so you asked the motivation behind this specific tooling. Well, we started to realize a few different things. One, agents were pretty good about writing the Flink SQL. So if you've used the APIs within VS Code before, you can actually have agents write even inside a notebook. And we started to play around with it, and it was like, oh, the agents are actually pretty good at writing Flink SQL without any additional documentation, right? Like we didn't need to prompt it other than saying, hey, use Flink SQL versus generic SQL. That's all we needed to do. And so that's the first thing we noticed. And then we noticed, well, we've actually baked a lot of functionality directly into the VS Code extension that could be essentially extracted. And if the agents had access to that, they could do it without any sort of the UI. And so how it actually works is even the VS Code extension that I showed, we're extracting all of that functionality out of VS Code into the CLI, and the CLI is now backing the VS Code extension. And so that's really where we noticed that. And then finally, in terms of like just people using Flink SQL in general, what I've noticed is people are very actually hesitant to try it until they try it. And then they're like, oh, this is like incredibly powerful and you can really do some really cool things. There's still a ton of work, admittedly, to do both on our platform in terms of management and like load management across our entire team. I mean, our manager's there. You can go ask him how much I complain about needing more people. But I think the reality is you just have to figure out what you could do and try and build the right tools. And if you build the right tools, hopefully you can load manage across all of it. So my team is responsible for everything from the infrastructure to this tooling to we have connectors, we have custom connectors, we have our own internal library, we have functions, we have observability. Like, so there's a lot to essentially manage across all of those. But I think we've done a pretty good job about building a strong foundation that we don't always need to touch every layer. And then it's essentially like, how do we build on top of a strong foundation is the goal. Cool. I think that's more or less it. Thank you very much.